A modern long-haul pipeline system's components include meticulously welded sections of high-strength steel and associated above-ground facilities such as compressor stations and measurement and pressure regulation equipment. These pipelines are constructed on what engineers call a moving assembly line. Building a pipeline involves a large specialized workforce, tons of steel pipe, mechanical equipment such as backhoes and side booms, and miles of environmental silt fencing that helps clearly define the work boundaries and prevent environmental damage and unnecessary erosion brought on by weather or other events during construction. Every step of the process is guided by company and contract engineers, designers, manufacturers, and craftspeople with years of experience in constructing natural gas pipelines. All meet and often exceed the highest governmental and engineering standards for safety, environmental protection, and operational reliability. Great effort is taken to minimize impact to landowners during the construction process. Every step of the project is carefully planned, and multiple construction crews are used along the pipeline route to install the system efficiently and restore the work area as quickly as practical to minimize impact to the public. Depending on the terrain, skilled work crews can install more than a mile of pipeline per day. Once in place, the pipeline system will be well marked with surface-level signage and well maintained, utilizing strict federal and engineering standards after being placed into service. Importantly, companies utilize a systematic process to promote pipeline integrity long before the systems are ever constructed and placed underground. Modern-era pipeline construction originates with specialized steel that is formed, welded, inspected, and tested to exact international specifications and in accordance with strict PHMSA regulations. The entire pipeline exterior is covered with a specialized epoxy coating, which is a tough corrosion-resistant covering similar to the coating on kitchen appliances. The thickness of the pipe will vary according to factors such as pipeline operating pressure and diameter, population density, and environmental conditions. Most long-haul pipe is between 20 and 42 inches in diameter. The larger the diameter and the higher the operating pressure, the more the pipeline can transport. An object-free and clearly defined right-of-way corridor is critically important to pipeline companies both during the construction and operation phases. While a temporary workspace width of about 100 feet is generally required during construction, the permanent right-of-way for a long-haul natural gas pipeline is typically 50 feet wide or roughly 25 feet on either side of the buried pipeline. This helps identify the presence of an underground pipeline. Along with above-ground markers strategically placed over or near the pipeline, there is no better visual reminder of underground utilities in an area than a cleared and well-defined energy corridor. Again, it's raising public awareness and the attention to excavation damage prevention that provides some of the best pipeline protection. On the right-of-way, work site preparation begins with the removal of all trees and brush from the construction work area. Stumps are removed over the width of the permanent right-of-way, with the exception of stream buffers and wetlands. Specialized heavy equipment is often used to assist in this process. Downed timber is often cut into usable lengths or otherwise disposed of after seeking landowner input. Grading is conducted where practical to provide a relatively level surface to allow safe operation of the heavy equipment required to excavate the trench and install the pipe in the trench. A trench is excavated that is wide enough to safely support the depth of the trench and to allow lowering in of the pipe without damage to the pipeline coating or harm to construction personnel. In some rocky areas, blasting will be required to excavate the trench. The steel pipe sections, or joints, in 40 or 80-foot lengths, are trucked to the construction work area and strung out along the route in the areas where they are to be welded together. As necessary, the pipe joints are bent to follow the route of the pipeline and contours of the ground. A specialized pipe bending machine is used. The amount of the bend in the pipe section is limited to avoid damaging the pipe or coating. Once the individual pipe joints are bent to fit the trench, they are welded together into long continuous sections which can be up to several thousand feet depending on terrain. The welding is highly controlled and performed by welders using proven international standards. Each weld made on the pipeline is visually inspected, and the welding process is verified with either radiographic or ultrasonic technologies. Welds that do not pass stringent requirements are repaired or replaced. A specialized corrosion protection coating is applied to each of the weld joint areas after the inspection is complete. The coating on the entire pipe section is then electronically checked for any coating problems and repaired prior to lowering the pipe in the trench. The pipe sections are lowered into the trench by special pipe-laying tractors called side booms. Care is taken to not damage the coating during this process. The pipe is placed in the trench on sandbag benches to prevent damage to the pipe coating. The coating is rechecked again. The ends of these completed pipe segments are then welded together in the trench to form a continuous pipeline. Once long sections of pipe are completely in the trench, the material excavated from the trench is carefully replaced over the pipeline. A layer of rock-free pad dirt is placed all around the pipe to protect the coating. As various sections are completed and the trenches are backfilled, the pipes are filled with water and safely pressurized to a point significantly higher than the maximum pressure the pipe will ever be operated to verify the overall integrity of the pipeline. This test pressure is held for a minimum of several hours to test the structural integrity and overall strength of the pipeline, and to allow minute water leaks to be found. Water bodies that need to be crossed are first classified by the FERC into three categories: minor, intermediate, and major, with the water body width at the time of construction as the determining factor of the category. Four basic techniques are generally used by pipeline companies to cross streams and rivers. The appropriate technique is chosen based on the sensitivity of the water body and/or the aquatic life living there. The technique known as horizontal directional drilling employs the latest proven technology to drill underneath the water body, leaving it in its natural state. The cleanup and restoration process starts as soon as practical after the pipe trench is backfilled and continues until the construction work area is restored and revegetated. All terrain is replaced to original contours as much as possible, and the work area is restored utilizing seeding and soil preparation specific to the affected area to restore ground cover and to minimize erosion. Temporary workspaces will be allowed to return to their previous state, either wooded or open. The permanent right-of-way corridor will need to remain free of most obstructions to signal to any passerby that underground utilities are present. Above-ground markers will be placed at locations such as road crossings and at various strategic places along the route to further indicate the presence of a pipeline. The markers contain important information such as operating company contact phone numbers and the commodity being transported. Upon completion of construction, the right-of-way typically may be used for most residential, commercial, or agricultural purposes, provided this use does not interfere with the safe operation, maintenance, inspection, and repair of the pipeline, or obstruct access to and along the right-of-way. Restrictions are documented in the easement agreements, but in general, permanent structures should not be placed on the right-of-way. Some examples of these types of obstructions include houses, decks, sheds, pools, and septic tanks. Also, tall vegetation or trees should not be placed on or near the right-of-way. Some items, such as driveways, fences, and improved parking lots, may be placed over and across a right-of-way if they meet certain requirements to protect the pipeline. Always check with the pipeline operator and easement restrictions prior to beginning any work. For more information about long-haul natural gas pipelines, please visit the Interstate Natural Gas Association of America website at www.inga.org.